Okay, so section 1.8 sort of shows all of our transformations, the old ones from our parabolas unit in grade 10, as well as our new ones. So the old ones are A, and then we used to call this H, and we used to call this K. Now it's A and H, or sorry, D and C, because the written letter K is our new transformation, which is our horizontal transformation factor and reflections. So it does stretches and compressions horizontally, affects the x values, and then it sort of can do reflections in the y-axis. Okay? So I'm going to try and stay over here and away from the board as much as I can to help this out, but I do have to do some doodles. So I'll have to, once I draw something, I'll have to pull away so you can see what I need to see, because there's been a bit of a brightness correction factor with my phone, a little bit of active editing. So hopefully we can weed that out. So for A values, if you remember what those are, they're vertical. And one thing that's important for you to realize with any function is if I multiply something on the outside of the operator, on the outside of the function, so for y equals x squared on the outside of the bracket x squared, y equals the square root of x on the outside of the square root sign, y equals 1 over x on the numerator or far off, added or subtracted. And on the absolute value function, sort of the same idea on the outside of those absolute value signs. Those are vertical things. Those are things that are going to affect y. So A is a vertical transformation factor. Okay? Causes vertical transformations. And the vertical transformations that it causes, okay, can be variable. Okay? If it's negative, if A is less than 1, it's a reflection. Sorry, less than 0, I should put, sorry. If A is less than 0, it's a reflection. If A is greater than 1, it's a stretch. And if A is less than 1, but A is greater than 0, then it's going to be a compression. And both with A and K, there's a lot of stuff going on there. So as a result, we have to sort of be a little bit careful about the value. But basically what it does is it multiplies all the y values by whatever that A value is. Okay? Okay? So logically what we would do along with this is to take a bit more extra of the room, and we would talk about the one guy that we don't know so well, the one guy that's new, and that is K. K is the horizontal transformation factor, okay? And so it ends up being K times. But it's not exactly K, it's 1 over K times. K is found inside the function. See, there's a square bracket here, so it's inside the function. So it would be inside the square root sign. It would be inside the bracket x squared. It would be inside the absolute value function. And it would be in the bottom of, or the denominator of the fraction, the reciprocal function. And K, okay, is always scooched next to the x. Now sometimes we're really supposed to factor out the K value. That's our first step before we even figure out what these values are and transform our function. So when you're working with K, don't forget to factor it out, but it will be either multiplied by an internal bracket with x and d, or it will just, the K will be beside the variable component, okay, of that function, the x. So it'll be very intimately associated with that. So again, stuff on the outside is vertical. Stuff on the inside is horizontal. Stuff on the outside affects y values. Stuff on the inside affects x values. And so we kind of have the same thing in this case. If K is less than 0, it's going to be a horizontal reflection. Okay? If K is greater than 1, it's actually going to be a compression, because you take the k value and you go 1 over that. So if k was, say, 2, 1 over 2, it's going to 1/2 all the values. And if k is greater than 1, it's going to be a stretch. Oops, sorry, less than 1, it's going to be a stretch. I'll have to fix that one too. Okay, because these are going to be your nodes. K is greater than 1, k is less than 1. Okay, it's going to be a stretch. Okay? Less than 1, then of course, I guess I should say less than 1 and greater than 0. K is greater than 0, then it's going to be a stretch. Okay, and basically what you're doing is it's going to be 1 over k times. So you look at the horizontal components, the x values, you count the squares, and let's say your k value is 2, you 1/2 that distance. If it's 2 squares, you half it to 1. If it's 1 square, you half it to 0.5, and so on. But we should have gotten used to that from last night's work in section 1.7, or last day's work whenever we're doing this, okay? D and C are a little bit easier. D is also inside the function, so it's also horizontal. And that's a translation, okay, a translation, okay? Basically what happens is if D is greater than 0, it's going to move to the right. If D is less than 0, it's going to move to the left. And remember, for these D values, it's once we take it out of the function. Okay? So horizontal stuff is inside the brackets, with the squared, under the square root, in the bottom of the fraction, within those absolute value signs. Okay, that's the horizontal stuff. That's the stuff that affects our x values. The stuff that affects our y values is on the outside. So we've got the a that's multiplied on the outside, so it's a times, and we've got the c who's added on the outside, and that's going to be a vertical translation. And all of these values are values after you take them out of the factored version of your equation. Okay? When you take them out, D has to sort of be modified. Okay? When you take K out, you do have to kind of modify it a little bit to see what actually happens to the transformations. Okay? So there is some modifications need to take place, but first we determine what these values are and then we go from there. And you have to factor out the K to get the correct D, so be sure that you do that. So for a vertical translation, it's just going to be, if C is greater than 0, if C is positive, then it's going to go up, and C is negative, it's going to go down. If it's 0, it doesn't go anywhere, okay? And sometimes we're going to have situations where it doesn't include one or the other, okay? So how do we sketch these with all of this stuff in mind, okay? Well, there's two sort of overall techniques that most people use, okay? I call one the step-by-step method, okay? And that's where we go from one to the next, to the next, to the next, to the next, okay? So first things first, before you do anything, if it says to sketch, whether you're going to do step-by-step or whether you're going to use the other technique, part B, you really need to go ahead and take this function here. You're going to see that this is a root function, okay, because it's got a square root sign. And within the square root, -2. Within the square root, see how there's a 2 beside the x, but then there's also a -6 in the square root? You have to factor the number beside the x out. That's your k value. So factor out your k value. 2x minus 6, I divide 2x by 2, and I get x. And this is always going to be x, no matter what this number is, whether it's divisible by the 2 or not. Okay? And -6 divided by 2 is -3. I've just made it a nice round number for you guys so that we can sketch it. And you got to do that. If you don't do that, then your D value is going to be wrong. You may get the correct K value, but your horizontal translation will be weird, okay, or will be off. All right, so what do we do? Now, this is a step-by-step process. So what I've done is drawn pictures and outlined as we go from one step to the next to the next. So what we do is we take our basic function, y is equal to root x. We recognize, hey, it's a root function, so we write down the root function. Here it is. That's the table of values. Perfect, okay? Then what we do is we factor the k value out, which is what I just did. So I factored that 2 out, okay? And then your next step, pretty easy, pretty straightforward, is to state your A, K, D, and C values. What are the transformations going to be? If you don't see it there, that means that that effect is not going to be felt. Okay, so if you don't have a number where there should be an A, that means that the A value is 1, and that means that there's no stretch, a vertical stretch or vertical compression. So it's immaterial, it's not important for your sketch. Okay, in this case, my A value is -2. If you go back to, I'll go back to the equation down at the bottom here. If I go back to it, there's my A value, -2. Okay, there's my K value, 2. There's my C value, +1. And then my D value, switching the sign, is going to be a +3. Okay? So there's my A. Maybe a different color. There's my K. And then finally, maybe I should erase that. Make that black. Okay, changing the sign, D is equal to 3. And then we don't change the sign for the for C. C is equal to +1 or 1. Okay? So that's what we do. We have to figure out what those values are. Now, from here, you should be able to use words to describe what happens. Here, my A value is -2. What that means is it's going to be a vertical stretch by a factor of 2. Okay, so it's going to get, the Y values are going to get doubled, and it's going to reflect, so it's going to be upside down. Now, this is a root function. So if you take your root function, it kind of looks like, I don't know, a curvy arm. Okay, it's going to be flipped upside down, and it's going to be twice as big. Okay, but we're going to do that step by step. We're going to take our time. That's what this whole process is about. We're going to take care of A. Then what we'll do is we'll take care of K. K is going to be a horizontal transformation. Now, there's no reflection in the y-axis, okay, but there is not a doubling, but a halving of all of my x values. Because remember, the K does the opposite of what you do. You multiply the values by 1 over K. Okay, whatever that is. So I'm going to be 1 over 2 or 1/2. And then for my D value, that's going to be a shift this way of 3. And that's my C value is going to be a shift upwards of 1. Okay? And we're always going to do things according to bed mass. So when you watch this step-by-step technique, oops, I'm supposed to go to the next one. All right, when you watch this step-by-step technique, okay, so you determine A, K, D, and C, and that's what the values are going to do. Okay, and then what you do is you move from one transformation to the next progressively. That means you move from one step to the next. That means you don't take your y equals x root x function and then do your transformation of your A value and then step back and then do your transformation of your K value and then you do your translation. You don't go back to the beginning. You step forward. You go, okay, first I'm going to do my A transformation, and then for my A transformation I'm going to do my K, and then for my K I'm going to do my D, and then from D I'm going to do the C. Okay, you do them step by step until you're done. Okay, and a lot of people do the D and the C value at the same time, but that's neither here nor there. So this is what I'm going to do. And what you basically do is you kind of go from left to right, really. Like if you take, you know, y is equal to A, oops. If you take y is equal to K, x minus D, I forgot my F, darn it. Y is equal to A, and then there's your function, okay? D. If you take this rule and you write it out and you go from left to right, you can never go wrong. Okay, so you do your A first, then what you're going to do, you're going to do your K, then what you're going to do, you're going to do your D, and then what you're going to do your C. If you go from left to right, you're going to be okay. It's not alphabetical, unfortunately, because A starts the alphabet and then C should be next. But we can't do it in that order. We have to do the multiplication. We have to change the shape of the function first, and then we translate it, okay? Because bedmass, multiplying, is going to be affected and offered and done before we do addition and subtraction, okay? So what we do here in this example is we do the A value first. So here's my basic function, okay? Now I do it in 2 steps. First thing I do is I reflect it. You don't have to do that. And then what I did is, for my reflection, I doubled the distances. You can go straight from here to here if you want to. You get your 0 y value, multiply it by -2, and you get 0. You've got your 1 y value, you multiply it by 2, and you get to -2. You take your 2 y value here at x is equal to 4. You take your 2 spaces here, and then you multiply it by -2. So 2 times -2 is -4, and it goes down to -4. Okay? But if you want to do a step, you do the reflection, super easy, same distance on either side. And then what you do is you do the 2 parts, so you double the distance, you double the distance. Okay, so however you want to do it, but this shows a step-by-step progression. Okay? And it shows how the table of values also change along with it. You'll notice the y values go from 0, 1, 4 to 0, 0, 0, 1, 1, 2, and they go to 0, -1, -2. That's the reflection, that's the negative value. And then here they get doubled. Okay? Oops, I put the wrong table of values on there. That should be 0, -2, and -4. But I guess I put the wrong table of values on there. That's weird. Oh well, sorry. So make sure you make that change. Okay, and I'll have to make that change in the picture of the notes when I have a chance. Okay? All right, so that's what's happening. So first, a value. Then we do our k value. Okay? Now try to remember our k value, we're going to be multiplying by 1 over k. Oops, sorry. 1 over, I don't know why I put a 4 there. Multiply it by so in this example, 1 over 2. We're going to multiply the x values by 1 over 2. Okay? And so what you'll see here is, this is my y is equal to -2 root x. So that's where I left off on the previous page after I did a. Again, it's from one step to the next step. So I go from my a value to my k value. So this is my a value done, and then what I do is I multiply the x value here, so the x value of 1, I multiply it by 1/2. So what it does is I take my distance of 1 and I half it. And I take my distance of 4 and I half it. And so what it creates is a function that's a little bit sort of stretched, if you will. Okay, it's horizontally compressed. That's what the 1/2 does, or it looks like it's vertically stretched. And they are kind of like, you know, the amount that it's stretched by is a different story. We won't get into that. But the point is that basically it's going to be compressed horizontally because we're multiplying by a factor of 1/2. And so you'll notice that the 0, -2, -4 that's in here, the y values, -2, -4, 0, the y values don't change. What changes is the x value that was 1 turns into 1/2, and the x value that was 2 turns into 1. Sorry, the x value that was 4, turns into 2. The x value that was 4 turns into 2. Okay? And we'll be showing you that a little bit more so when we do our other technique. Okay, we don't really have to do a table of values with things at all times. Okay, we're just doing the step-by-step transformations. Now what I'm going to do is I'm going to do D, then I'm going to do C. And I do them in separate things, but a lot of people just go ahead and do D, and then they do C at the same time. Okay, so this is the function y is equal to -2 square root of 2x. So it's got my a value and my k value. So now I've stepped on my a, done my k. Now I'm ready to do the D, and then I'm ready to do the C. Okay? So, from here, what do? I take every point, and I shift it to the right 3. Shift it to the right 3. Shift it to the right 3. Okay? That's the D value. And then what I do to that one is, after I've got this function set up for me, then I shift it up. I shift it up 1 unit. I shift it up. So this goes up 1, this goes up 1, this goes up 1. Everybody goes up 1. Okay, everybody goes up 1. All right, I think I sketched the wrong function here. Yeah, this should be like here. This should be like here. And this should be like here. So the function should look like this. I'm going to have to fix this note. Darn it. Okay, the function looks like this. Okay, so So try to ignore that for now. Okay, that's what the correct function should look like. And so again, you're going to see the movement of 1, 2, 3, a little bit 1, a little bit 2, a little bit 3, and then here you're going to see 1, 2, 3. Okay? But for the final function, this one is correct. And then this one, again, what do? I shift it up 1, up 1, up 1. Okay? And so I move over to the right 3. So my d value, if you remember, was positive 3. So I move 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, 3 spaces. 3 spaces. Okay? And then here, I take each value and I move it up 1. I move this guy up 1. And I move this guy up 1. Okay? Again, modifying the x values and then modifying the y values. What some people do is they'll go 3 and then up 1 and do them both at the same time, which is perfectly fine in these step-by-step transformations. Okay, if you remember, the c value was +1. Okay, and that's what I did there. All right? Finally, we have our function. So the only thing that we generally tend to do afterwards is state the domain and the range of the function. Okay? Now, one thing you're going to start to understand as you do more and more and more of these, domain, of course, describes x such that, okay? What you're going to find out is, as long as you can visualize the final function, it's pretty easy to do the domain and the range. Here's my final function. Oops. Move something there. I want to do that. There's my final function. Good. Okay. So there's my final function up here, this green guy here, okay? But we're going to go back and we're going to look at the original function because we can actually see some interesting things and actually predict the domain and the range without even looking at the graph of it, okay? So what you're going to find out is, first of all, the domain goes from this value to the right, okay? So it's got to go basically from the 3 to the right, okay? And so when I state the domain, x is going to be greater than or equal to a 3. Okay, and that 3 isn't a coincidence. Okay, and then as long as it does that, x is a number of real numbers. Okay, we go back and we look at the y values all the way down here for this function. Okay, so for this green guy right here, green guy, okay, you're going to notice that the x values sort of stop here, okay, so x is going to be greater than or equal to the 3. But the y values for a range, okay, the y values, no problem down here, they go on forever, but here, they stop right here, they stop right at 1. And that's not a coincidence relative to our values as well, okay? That's not a coincidence relative to our values as well. So y is such that y is going to be less than or equal to, and in this case, 1. Y-E-R. Now, in general, what you're going to find, and this is no coincidence, because this here, that's your d value. This here, that's your c value. Okay, so it's not a surprise. That's the location of kind of the vertexy part of that particular relationship. But we also have a greater than and a less than, so how do we know? Well, the less than is because we have a negative a value, right? If we have a negative a value, that means that rather than going upwards and being greater than, it becomes less than, okay? And this one is because we have a positive k value. So if you have a positive k value and a positive a value, it's going to be greater than, like the normal function is. But if you have, I'll make a better note over here, we have a negative a value. And because we have a negative a value, then it becomes a less than. Okay, so you can actually look at it and figure it out, okay, just by understanding what the transformations are. So basically, the barrier exists at D and C for a root function. And the greater than and less than exists when my k value is positive or negative. K, remember, affects x, so it's going to affect the domain. So if k is positive, this is greater than. If a is positive, this is greater than. But in this case, a is negative, so it's a less than. But a is positive, it's a greater than. So the sign greater than or less, greater than or equal to or less than or equal to, is determined by the positive or negative nature of a or k. But that's just sort of getting used to the idea. You can go ahead and sketch the function if you want. The other way to do things is something called the mapping rule. Okay? The mapping rule. Okay? And when you do the mapping rule, what you have to do is the same thing that you would do to start off the step-by-step rule. The step-by-step rule, first thing we have to do is we have to factor out the k value. We always have to do that. Okay, so factor the k value out. And then what do we do? Well, we're like, okay, a is equal to negative 2. K is equal to negative 0.5. Okay? D is equal to, switch the sign, negative 4. And then K is equal to negative 1. Okay, just as we see it. All right, so then we got to determine what those are. So state A, K, D, and C. Remember what a negative 2 for an A value is. It's a vertical stretch and a reflection. What a k value that's negative is going to mean is it's going to be a horizontal reflection for the negative, and the 0.5 is 1 over 0.5. It's actually going to be a 2 times larger. So it's going to be a reflection. So I guess like this, it's going to be reflected in the y-axis, and it's going to be stretched horizontally. Okay? A d is equal to negative 4. That's just going to take my every point on my function and move it to the left 4. Okay, and a k value of negative 1, that's just going to move every point down 1. Okay, and we do need to use the words to describe these transformations. That is an expectation. Okay, so how do we do this mapping rule? It's actually quite easy to do as long as you're good with your arithmetic and you get this right. But you have to be good with your arithmetic, negatives and positives and whatnot. So list the points that define the parent function. Okay, so start from the parent function. In this case, it's a root function, so 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and there are the points right there. Then what I do is I take, oops, it's because I have my marker in my hand. I'm moving things. I take my formula, okay, and my formula for any point, this is for y is equal to f of x, and transform it into y is equal to a, oops, a f k x minus d plus c, the whole darn thing. Okay, that's all transformations. This is my parent function. So the point for my